A while ago, I wrote a blog post about exploding joins. Okay, so what does it mean? Because definitely you'll find this as a subject also in certification exams at Snowflake, in SnowPro certification exam, and Snowflake describes this, yeah, in their documentation. How to deal with this, yeah, how to deal with this. But first of all, let's understand what they are. So you may have, let's say, joins like these ones, yeah, one-to-one joins, no problem. It's not about one-to-one, but not too many joins. You see here, when you look in the query profile, you'll see a join block, okay? And this is an equi join in this case. But look, if you have input rows and output rows in relatively the same number, okay, this is fine. But you may have exploiting joins when the rows that you combine generate a huge number of output rows. Okay, like here, look, you have 95, you have 200, 250k as input, total input. Okay, and after the join, this generate 571 million rows. So this is huge. Okay, this is close, yeah. This is close to a Cartesian product, yeah. But usually there is an on condition there, but you have a large number of related records in the other table, yeah. That's a proper explanation, yeah, on this join. So you have a relationship here between, okay, but for each row, yeah, from one side, you may have a huge number of rows on the other side, yeah, and the other way around. So in this case here, I just wrote a small utility, but could be very useful for exploiting joins. I call it exploding join detector, and this is a UI. Yeah, that's a Streamlit application, and you can specify here the minimum factor, minimum multiplication factor. Yeah, you've seen that in the previous case, it's been more than 2,000 times. Yeah, the output rows than the input rows, the total of input rows, and this is a minimum factor. Yeah, so you can say I want the minimum factor. I don't know, 300. Yeah, let's say. Okay, I want 1,000. Yeah, I just set some limits here, 700. Yeah. This will look in the query history right now, on the query history from account usage. So this will look for all specific select queries with, yeah, we'll review this one because I try to filter out, yeah, most of the queries that may not have this kind of problem, okay? And so we look back 1, 2, or 3 days, yeah, let's say 2 days, okay? And here, yeah, definitely how many queries, yeah, you look back. And let's say, yeah, you may look 200. Once again, these are some typical filters. You establish them and then you say go, okay? And this is doing processing. And once again, yeah, we'll look at the code, what's happening, but let's build this application. You have a setup SQL file and a streamlit.py file attached to this lecture. So let's start with the setup SQL. Yeah, copy it into a new SQL worksheet as usual. And look what I have here. Okay, I will issue this specific query. Okay, this query will be, that's a query that I have online. Okay, I just established some context here. Yeah, let's run this context first, and then I just looked for this specific query that is supposed to generate. Is supposed to generate a lot of exploding joins. Yeah, that's the same query that you've seen that I used online. Let's try to explain it first. So remember, this will not execute the query, but this will suggest a query plan. Yeah. But as you can see here, yeah, definitely I have a join filter, but inner join, yeah, that's the one that we look at. But I don't have any information about the quantity of data here because when we do not execute the query, explaining this case is a bit useless. So we'll have to look at the query profile in this case. We'll have to execute the query, okay, and look at the query profile. And programmatically, what you can do is to call this function, yeah, is called get query operator stats, and it takes a query ID. Okay, so definitely you'll have to execute the query first. We'll get the query ID from the last query, yeah, last query ID. Yeah, we'll do this, and let's run it, guys. Okay, you know what I'll do? I'll do something else. Okay, I'll execute this one, which is supposed to take longer. But look, make sure that make sure that you did not execute this. You do not execute it from cache, because I'm afraid this is what I did here. I executed a few hours ago, and it comes from cache. So I just added an alias here that I never used before, and right now we're good. Okay. And yeah, as you can see, this will take longer, about 2 minutes. Yeah, let's see. Okay, so on my own, this took 2 minutes and a half, and yeah, you may get different results in your own if you try it. And this returned, as you see here, 571 million rows. Okay, and this is a query ID. You know what? I will copy it here. Okay, and I will also click on this one, because this will open in a different tab the query profile, basically for this query. And yeah, as you can see here, this is where the exploding join happens. Yeah, that's the exact same situation as the one that I illustrated. uh, this will produce a huge number of rows when a moderate number of rows have been considered, have been joined together. Okay. Okay, guys, so I executed the next sequence, as you can see here, and this ended up with a call to the table function, get query operator stats. Okay, and what are we looking at? We're looking at this specific operator type, join. Okay, and look, the information is here right now. Yeah, input rows, output rows. You see, this is what we care about. And the input rows is a combination between what you get on the left side, on the right side. Okay, we're interested in the total number, and the output rows as before. Yeah, 571 million. So a lot. Okay. How can we automate all this? Yeah. How can we look, let's say, into query history? Look, we have the information schema, query history here, and we can look, let's say, 1 day behind. Okay, up to today, okay, and look at maximum 100 queries. And look, we look only at the queries we select and execution status success, okay, order by start time. Yeah, we don't want anything else. Have a look at this. That's a system view. Actually, sorry, that's a system functions. That's not a system view in this case. Yeah, you see the call. Yeah, the call should be from table query history, and you pass some parameters here. And yeah, this is the information we have. Yeah, this is information I collected, and I get query IDs here because yeah, this one should be passed right now. You see, what if I join this one with get query operator stats, and I pass the CTE query ID? And the way you should do it is to call lateral. Yeah, is to call lateral. Yeah, let me get rid of this first. Okay. So this would be a query that is supposed to work. Yeah, it's supposed to work. I created a CTE with a query I had before, and then look what I did here. Yeah, look what I did. I filter everything by operator type join, and I have to have the factor greater than 1,000. So I have to have more than 1,000 rows than the input rows outside, more than 1,000 the number of input rows as output rows. Okay, because in this case we can be talking about exploding joins. So once again, this is subjective here. It will be up to you to consider this factor or not. And yeah, I return also. You see, I go into JSON data, yeah, and I get the input rows, output rows, join type, equality join condition or additional join condition. Okay, because it depends. If there's not equality, could be something else. Let's try to execute this one. Yeah, this should work, you may say, and surprise, surprise, this is not working. Invalid value. Okay, for the query ID to the function, to this function. And yes, that's a problem, guys. The way they created this function here, the way they created this function is it takes only a string, it takes only a session variable. Okay, you cannot pass here dynamically the values from columns from record set that you executed before. Even if okay, lateral is supposed to be used in this kind of situations. Okay, so yes, I'll leave you a link also as the people found out this, and there have been discussions and hacks how to do this on the net on Stack Overflow. Okay, I'll point you directly to this one. I will leave it there. It is what it is, but there's something that complicates all this because other people asked about an utility to do this. And what's interesting, they required for such a function because they wanted automation. Yeah, they didn't want the nice looking query profile that they had on screen. They needed something to study a bunch of queries, the performance of a bunch of queries. And definitely this was a goal. The goal was somehow to query the query history, to look at the executed queries, and then to call get query operator stats. Even if this consumes some compute credits, yeah, it's our choice. It's our choice. Yeah, it is what it is. What can I say? It's sad, but I try to look for a different solution. So first of all, yeah, that's not the only problems that we'll have. If you call information schema, yeah, with query history from a Streamlit app or from a procedure, this will execute always with owner rights. Okay, and that's a problem because this is actually for caller rights. Yeah, I'll not get into all the details. Long story short is we cannot use information schema, the query history. We should look at account usage query history. So this is also good, but this is long term, and this will have a latency. So if I execute it right away, let's say a query, this may take several minutes until I will find that query in my query history. Okay, and yeah, look, guys, what can I say? This would be the query that I will execute from the Streamlit app. Yeah, is using query history, and I added more filters here. Okay, I will dynamically provide how many days back I must look, and the limit of queries. Yeah, I can do it this way. Yeah, query history in this case is a system view, is not a system function. Okay? And look, I will filter. I will look only at select queries, successfully executed queries. Yeah, I need by scan, yeah, greater than 0. Sometimes there are metadata queries. They don't query any data. Totally elapsed time. Yeah, more than this comes in milliseconds. More than 10 seconds, let's say. If a query took less than 10 seconds, I don't care if they had exploit. Enjoy it. Yeah, this means that okay. Warehouse name, yeah, they should be executed by a warehouse, and is client generated statements false. So this is not UI query. Okay, so if I do this now, yeah, let's try to run it just to play a bit with this one. This should work. This should work. Okay, so far I have 4 different queries here. Yeah, 4 different queries, and let's see. I will pick up definitely query IDs, and separately in a cursor. Basically, I will try to execute. Okay, I will try to execute this one. This one, as you see, that's a query that calls get query operator stats. But as you can see here, what I did in this case, I will execute this one just for the query ID, the session variables that I saved before, and here I separated specific fields. Let's play with this just because I want to see how it goes. But this will be executed from our Streamlit app for every individual query ID. And if there are output rows, this means that, yeah, potentially we have an exploding join problem there. Okay, guys, switch now to your Streamlit apps. Yeah, assuming that you created a new Streamlit app and copied and pasted the Streamlit.py content here. This is what I did here. Yeah, I changed the title and I already executed this one. But let's first have a look at this. I was talking to you about. I was telling you about the second the two last two queries. Okay, that's the first one. Looking at the query history. Okay, query history, account usage, and for each row here, I will pass. You see here, I will pass as a string the value of the query ID, get query operator stats. This way it works. Yeah, but yeah, you may see that I'll have to execute each time query get query operator stats. So a lot of queries could be executed. That's why try to find, if you want to extend this application, try to find the right balance. Okay, if I find data here, because look, I will look at the top row only. If I have more than one exploding join in a query, I don't care. I want to find the first one. Okay. If I have the first one, okay, I will send the information here and I will, with markdown here, I will send it on screen and I will use an SD markdown. I not use, you see, I already executed this one here. I not use a data frame control because, yeah, some information could be large enough, like query text and so on. So it's hard to see, hard to watch. So, yeah. Look, I can execute this again, but my computer got very slow because I run a lot of processes. Have a look at this one. What I return, yeah, definitely in this case, you establish min factor, days back, max queries, and so on. Then you click go, okay? You may get one or several entries like this one, and yeah, this will tell you the query text, the query ID, start time, total elapsed time. Once again, it will be up to you to select by scan, yeah, rows produced, and here that's the information coming from the get query operator stats, input rows, output rows, the factor, okay, how many times the output rows are bigger than the input rows. Okay, the join type and the join condition. Okay, to recap, an exploiting joins problem is when you get an enormous number of output rows after a join when compared to the input rows. So it's always based on the input rows because, yeah, in this case, if you select already 500,000 rows in the input joins, yeah, you expect a large number of joins on the output. So definitely, that's why we calculated a rate or a minimum thresholds, let's say, for this factor of multiplication between the input joins and the output joins to be considered, yeah, as exploding joins. It's a subjective measure once again. So we created this exploding join detector. Yeah, this is how it looks like. You see the minimum multiplication factor here. It's on the left. Yeah, I just came up with some criteria, and this will look into the query history, basically queries that you already executed. Yeah, by ID. You must have queries that you executed because otherwise you don't find the quantities of bytes scans, how many input rows you have, how many output rows. Okay, so in this case, because we created a Streamlit app, I had to use the account usage query history and not the information schema. So our implementation here uses get query operator stats, yeah, where you'll have to call this built-in function with a query ID. Yeah, the query ID, so the query has been executed before, and the query is in either information schema or account usage query history, but we'll look into the account usage schema. Okay. Explain is useless. Within this, cannot estimate IO bytes, must execute the queries and look at the query profile. But that's why this was the goal, to find an automated method. And this why this gadget is useful after all. We cannot call the function with lateral join. Yeah, we've seen this call for each query, and that's a generic problem. Yeah, I remind you that they created get query operator stats with some limitations. Yeah, you cannot pass as query ID a column from a previous result set. It is what it is. Yeah, check the references that I left you there, because there are Snowflake employees discussing this one and coming up with some hacks. Information schema, query history cannot be used from the app. Okay, that's a different problem. That's a limitation with Streamlit apps, and that's why we must use account usage query history view. But this comes, remember, with latency. However, more queries are saved there. But be careful, because this will your query will parse a large amount of data. I added this criteria here to look n days back at maximum m queries. And yes, we established this condition, exploiting join if output rows divided by input rows on a join operation type, okay, is greater than, let's say, I don't know, 1000 or so. Yeah, it will be up to you, because it is all subjective.